In this session, we will discuss about the integration by parts technique for integration. When we are going to discuss about the integration by parts method, this can be used to identify the integration of products of functions. Now we will see what is actually defined by this integration by parts technique. Now think about, let u and v be function of x. Then if the function is defined as the multiplication, now think that what we have discussed in the differentiation was, if you are having multiplication of a function of two functions u and v, where u and v be the functions of x, and what you have done here was, first of all, you have isolated a single function, u was isolated, then v was differentiated with respect to x, and then v was uh, isolated and u was differentiated with respect to x. This is what you have done, what we have discussed in the differentiation. In the previous sessions, we have discussed about this matter. Now, what we are going to do is, you are going to get the integral. You are going to integrate this function for the both sides. Then the integral of both sides with respect to v, with respect to x, gives you the final results as integral of u dv equals uv minus v dv. It is quite like, if you are getting the integral with respect to x, it is by integral of d over dx uv dx, then is equals to integral of u dv over dx dx plus integral of v du over dx. Therefore, if you perform this integral appropriately, then you will just get this as uv in the left hand side. Here you will get integral of u times dv, and this plus integral of v times d. And for the calculations, even though we are getting the function in this form, but for the calculations, you cannot apply the same form. Therefore, what we need to do is, we need to convert this into appropriate form. Therefore, I can isolate integral of u dv in one side. Therefore, I will take integral of u dv in one side, integral of u times dv. This is now equal to uv minus integral of v du. This is the method that we are calling as the integration by parts technique, and this equation will be used for calculations for integration by parts technique. And actually what we are going to do here is, here we will consider integral of two functions when it is given as a integral of function when it is given as a product of two functions. Now you may be able to identify one function would be u and other function will be considered as dv. If you have identified first function, one function as u, and another function, the next function as v, then you can apply this integration by parts technique to identify a proper integral value for this. Then when we are going to identify this function u and dv, the function u and dv, you can uh, stick into this concept. This cannot be actually say as whole. It is just a concept, and in this concept, according to this concept, you can easily identify the function u. Once you identify the function u, then the remaining would be considered as the function dv. First of all, you need to identify function u according to this concept, and then the remaining part of the calculation would be considered as dv. identification of function u, then you can use this technique isolate. Isolate can be used, but here what you have to do is there is a change in this exponential and trigonometric. It is this exponential has to come upward on top of this trigonometric function. It is actually the order is I L. This is the actual order where I is denoted as I stands for the inverse function. If you are having inverse function in your calculation, then priority should be given for inverse function, and you have to take inverse function as u. Then logarithmic function, the next priority goes for logarithmic function denoted by L. Next priority is for algebraic function denoted by A, and next priority is for exponential function, which is denoted by E. Next, the least priority is for trigonometric function, which is denoted by capital T. Therefore, always the topmost function should given as the should given the priority, and you have to name it as function mu. Now think about these two cases. Now if you get the integral of, now think about this case, if it is integral of inverse function and a logarithmic function. In this case you have to identify inverse function as u and logarithmic function as d. If you consider another case, if you consider another case as if this is the integral of if this is the integral of logarithmic function and exponential function, logarithmic and exponential, then this has to be given the priority according to this should be u and exponential part should be dv. And if it is exponential and algebraic, if it is exponential function and algebraic, then according to this concept, algebraic should have the function u. Therefore, a should given as the function u, and the remaining part would be given as dv. Therefore, according to this concept, the topmost function listed in this should identified as function u, and the remaining should identified as dv. Now this is one example to identify using the uh, integration by part technique. Here what we need to do is we are asked to get the integral for x times e to the power x dx. This is what they have. If we write it here, it is x times e to the power x dx. This is the given function. And inside this function, you can see that this is actually a multiplication of two types of function. Here we can see that x is an arbitrary function, x is an algebraic function, x is an algebraic function. Then the remaining would be, then this part would be an exponential function. This is an exponential function. According to the list that we have considered previously, you need to give the priority for u accordingly, according to isolate, but at the end these two should be interchanged. E and t now interchange value were given. Now if you compare the position of this a and e, algebraic and exponential, algebraic is has now become on top of exponential. Therefore this has to be considered as function u. Therefore this has the function x has to be now considered as function u. This is the first step that we have to do once you need to apply the integration by parts technique. Therefore now you can say that this is considered as function u. Then I can write it here. Now u is equal to x. Since we are using the integrating by parts technique, it is integral of u times dv equals u times v is u times v minus integral of v du. This is what we have obtained as integration by part technique. In this technique, what you have obtained was, now if you match our equation or expression with this theory, then here you can see the integral notation. Now you have identified x as our function u. This is our function u. And since we have completed up to this point of this function, integral is okay. Now you have identified u. Then what would be the remaining? Remaining would be dv. Therefore, the remaining dv can be now considered as e to the power x dx. Therefore, this can be considered as now dv. Including the dx term, you have to consider for dv. And now you have already identified this as function. Then you can write them separately. Here you can see that I have written u equals x and dv is now equal to e to the power x dx. U is equal to x, dv equals to e to the power x dx. The quantity that you have identified u as u has to be differentiate with respect to x. Once you take the derivative of u with respect to x, then you will get du over dx. This equals to dx over dx. Therefore, you can obtain du over dx equals to 1, and using it we can obtain a value for du. Therefore, prior for this calculation, if you again look back to this equation, this is what we need to identify. And if you need to evaluate this, what you need is, you can list them here. You need the function u. You need a function for u. You need a value for v. And here you need a value for v, as well as you need a value for du. So far what we have identified was, we have obtained a value for u equals x. Therefore, now we have fulfilled this. Then if you have fulfilled this u, then we need to identify what is the value for v and what is the value for du. To identify the value for du, you can use the equation where the function equals to u. And this dv part can be used to obtain value for v. Therefore, you can use this to obtain value for v, and this can be used to obtain value for du. Therefore, what I have done here was, here I have differentiate u with respect to x. Always you have to differentiate u with respect to x using the appropriate technique discussed under the differentiation technique. And then using the calculation procedures, then you have to identify a value for du. Then in this example, now we have identified du also. Now the completed parts are u is completed now, du is completed now. Therefore, the only remaining that the quantity that we need for the calculation is quantity v. Now we need to identify a function for v. To identify a value for v, so far we are having value as dv, If you write it here, it is quite same as dv can be written as 1 times dv can be written as 1 times dv. And if you integrate both sides, if you just use the integral for both sides here, you can simply understand integral of dv is equal to integral of 1 dv. Therefore, you can see that integral of 1 dv is quite equal to v. It is the concept of integral of 1 dv. You see, since previously we had the term x here, we got the answer as x, but here we are just taking value as v. So for the integration by parts, here we are no need, it is no need to consider for the arbitrary constant. We can consider it as the end of the calculation. Therefore, we will simply take value v using the integral. Then if you apply the integration for the left hand side as well as the right hand side of the equation, then we will end up with integral of dv equals integral of e to the power x dx. If you perform the integration in left hand side, we will get the value as v, and for the right hand side we will get the value as e to the power x. Integral of e to the power x dx is equal to e to the power x. Therefore, now we have identified a quantity for V also. Now, all the requirements are fulfilled. Since all the requirements are fulfilled, now what we need to do is we need to um, apply them in this equation. We have to apply them properly in this equation. Therefore, if you try to apply them properly in the equation, here we have the right hand side, left hand side is now quite okay. It is because we have already identified. Now our function is in the form of integral of u dv. Then in the form of integral of u dv, we have written down the left hand side of this equation. It is integral of x times e to the power x dx. Then you can apply the this integration by parts technique for the right hand side using this equation. Then it is now u times v. The function u was identified as x, therefore I am writing x here. I am the equation I am getting here is this. I am doing substitution here. Then instead of u, what I got was x. Instead of v, what I have found was e to the power x. Here I have obtained the same quantity here also, x times e to the power x. Then this minus integral of the value of v was e to the power x, and value of du was dx. Value of du was equal to dx. Now, this is a very simple integration that we can perform. It is quite like integral of an exponential function. Integral of e to the power x, here, integral of e to the power x dx simply gives the value as e to the power x. Then we can perform this calculation. It is e to the power x times e to the power x. It is as it is in the previous. Then this minus integral of e to the power x dx du was equal to dx. Therefore, we will get this as e to the power x only. Now all the integrations has now finished. Therefore, you can add the arbitrary constant c here. This is how we are using integration by parts technique to obtain a value for a integral of any given function. Therefore, this is the fundamental idea of the integration by parts technique, and we will see some other examples, several examples for this part. And if you move to the next example, here you are asked to get a value you asked to get the of integral of x times ln x dx. Here, what we have to do first is, first of all, you have to look for the Euler concept. When you are writing Euler concept, T and E should be interchanged. Then, according to this example, you can see it is just the integral of x times ln x dx. Here you can see that x is an algebraic function. X is an algebraic function. Ln x is as logarithmic function. According to this order, then topmost has given you the priority for function u. Therefore, according to this concept, you can see that L is on top of A. Logarithmic is on top of algebraic. Therefore, first of all, you need to identify the function u. Therefore, we have identified function u is now the logarithmic function. Since the next function is algebraic, then you can get value a function for u is equal to ln x. This is what you have obtained as function u. This is what you have obtained as function u. Uh, and the next thing what you need to pay the attention is towards the integration by part technique. It is u times dv equals uv minus integral of v. Okay. According to this, now you can see that this is what we have identified as function u. Now this part has identified as function u. This was our function u equals ln x. Then the remaining has to be taken as dv. Therefore, if you see about this calculation, you can see that u has taken as lx and the remaining part is x times dx. Remaining is x times dx has now taken as dv. Then it matches with this integral of u dv format. Therefore, if you need to apply this u dv format, you need to identify value for u. You need to identify value for v, then you need to identify value for du. So far we have identified value for u. It is quite okay now. We have already identified value for u, and now we will need to identify value for v and du. To identify the value for du, what you can do is you can differentiate this function. You can differentiate this function with respect to x. Once you do the differentiation with respect to x, du over dx would be d over dx ln x. Then derivative of ln x with respect to x is 1 over x. Therefore, we will get this as du over dx equals 1 over x. Using this equation, we need to subject the quantity du. Then you can see that value for du is equal to 1 over x. Then these are the important parts for the calculation. Therefore, I am highlighting them. U equals ln x is needed, du is needed, and we need the next quantity is dv. This dv equals x times dx is given, and using this dv we can obtain a value for v. To obtain a value for v, what we need to do is we need to integrate the both sides of this function with respect to v. We need to get the integral of both sides. Then if you use the integrals here, integral of dv is obtained. Here we will get the integral for x dx. Integral of x dx, it is quite in the form, it is integral of x to the power n, where n is now equal to, we will have n is now equal to 1. Therefore, we will have this as x to the power 1 dx. X to the power 1 dx gives the value x to the power 1 plus 1 divided by 1 plus 1. Then we will get this as x squared divided by 2. Therefore, you can see now value for v is equal to x squared divided by 2. Now you can apply the quantities in the function u dv equals uv minus integral of v du. If you perform the calculation, value identified for u was ln x. This is ln x. It is the value identified for u, and the value identified for v was equal to x squared divided by 2. Value for v is equal to x squared divided by 2. Then you have to definitely use the bracket sign once you are dealing with natural logarithms. Otherwise, you may think that you can multiply this x with x squared divided by 2. Definitely, you cannot do it. This x quantity is inside the natural logarithm. Therefore, the whole function should be now multiplied with x squared divided by 2. Then this minus integral of, now you have to take the value for v. It is equal to x squared divided by 2, then value for du was equal to 1 over x d. This is the value what you have obtained for du was equal to 1 over x dx. Now, prior to perform this integral, it is better to solve this as much as possible. If you pay the attention for first part or the first term, it is x squared divided by 2 times ln x and this minus. Now you can see constant 2 is here, therefore I can take it out of the calculation since 2 is a constant, and x squared and this x, 1x will be cancelled out and remaining would be again integral of x dx. It is just using this calculation, you can see this 1x has cancelled out with this since you are having squared, 1x is cancelled out. Therefore, the remaining would be x after cancelling out, and this 2 has taken as a constant out. Then, if you get the integral for this, then this whole thing comes down as it is. It is quite x squared divided by 2 times ln x, and this minus half times integral of x with respect to x for x squared divided by 2. And now you can add the arbitrary constant since all the integrals has now finished. Then you can get the final answer as x squared divided by 2 times ln x minus x squared divided by 4 plus c. This is how we are obtaining the final answer. And you can see this calculation has also included, the calculation is like this. Now you can see all the values included, and uh, the calculation ends up with x squared divided by 2 times ln x minus x squared divided by 4 plus c. Okay, the third example is to get the integral for ln x. So far, when we discuss about the integrals of functions, still we have not paid any attention towards obtaining a value for ln x, integral of ln x. But if you go for the derivative of ln x, if you get the derivative of ln x, then you have obtained this as 1 over x ln x. Therefore, if you integrate this, if you integrate 1 over x, then you have obtained this as ln x. It means if you obtain integral of 1 over x dx, then you can obtain this as ln x. Therefore, now we have to pay the attention what will we get if we have the function as integral of ln x. Now we need to identify what is this quantity. To identify the integral of ln x with respect to x, we need to apply the integration by parts technique. If you apply the integration by parts technique here, as soon as you see this function, you can see that it is quite a single function. Integral of ln x dx. There is no any given product here, but this can be converted into a product. Just multiply this by 1. It does not make any harm to the function. The values may not be changed. It is 1 times ln x dx. Therefore, now you can see that these are two separate functions. One is function and algebraic. Ln x is logarithmic function. Therefore, accordingly, you can identify the the type. One is algebraic form. Ln x is in the form of logarithm. Therefore, if you use the islet concept, then logarithmic is on top of algebraic. Therefore, in this direction, you have to give the priority for function u. Then you can identify that u is now equal to this logarithmic function. Therefore, we can easily say value for u is now equal to ln x. Since you have identified value of u is equal to ln x, then you can get the remaining of this function. Then dv is equal to the 1 times dx. dv is equal to 1 times dx. If you apply the integration by parts technique, then you need to identify the quantities u, v and du. These are the things we need to identify. If you are going to identify these quantities, now you have already identified the quantity for u, and I will write the function also. Integral of u times dv is equal to u times v, this minus integral of v times d. To apply this integration by part technique, you need to identify function u. Function v is needed to identify. Function the quantity for du is needed to identify. So far we have completed identification of u, and u is now ln x. Using the function u, you can obtain a value for du. If you differentiate u with respect to x, at the end you can get a quantity for du. According to this calculation, we have obtained value for du is equal to 1 over x dx. It is completed. Now, so far we have identified a quantity for dv. dv was identified as dv equal to 1 times dx, or it is simply say, you can say it as dx, or it is 1 times dx. Then using this quantity you can identify a function for v, then integrate both sides, then integral of dv equals to integral of dx, then you can get this as this equals to v equals x. This is equal to v equals x. Now you can apply the values, or you can substitute the values in the function. Then this is the proper substitution gives value for u is ln x. Value for u is ln x. Value for v is quite x. Then integral of v is x, and du is 1 over x. Fire for the integration, you can cancel out the terms which are common. Then you will, with this calculation, then you will get this as x times ln x. It would be x times ln x. Then this minus integral of remaining is 1. Therefore, if you perform the integral accordingly, then you can get this as it is x times ln x, this minus integral of 1 with respect to x is x, and at the end you need to add the arbitrary constant c. This is how we are obtaining the integral for natural logarithm. Therefore, integral for natural logarithm is equal to x times ln x minus x plus c. And another example is included for this. Here you are asked to obtain the integral of x squared ln x. Here you are asked to obtain the integral of x squared ln x. According to this concept for integration by parts technique, first of all we need to uh, apply this Euler technique. According to this, x squared is algebraic, ln x is logarithmic. Therefore, u should be equal to ln x. U is ln x, and dv is now x squared dx. This is equal to x squared dx. Then applying the concept, we can take the values for du by taking the derivative of ln x with respect to x. Since u is ln x, we can take the derivative of u with respect to x. Therefore, you can get simply a value for du equals 1 over x dx. Then you have identified value for the quantity for dv, it is x squared dx. Then if you integrate both sides, then you will get the value for v equals x cubed divided by 3. Value for v is x cubed divided by 3. Once you apply the integration by parts technique, then the proper substitution gives you, if you write it here, integral of u dv equals uv minus integral of v du. Then this gives value for u is ln x, v is x cubed divided by 3. Then this minus integral of v du, v is x cubed divided by 3, du is 1 over x. Therefore, once you do the calculation, then x cubed divided by 3 times ln x would be the first term. This would be the first term we are having. Then 3 can be taken out as a constant. Then the remaining would be x squared dx. Therefore, we will get the answer as x cubed divided by 3 times ln x minus, if you get the integral of x squared, you will again get it as x cubed divided by 3. So here you will get 1 over 3 times the integral of this part is again x cubed divided by 3 plus, now all the integrals has finished, therefore you have to add the arbitrary constant. Therefore this leads to the final answer as x cubed divided by 3 times ln x minus x cubed divided by 9 plus c. This is how we are applying the integration by parts technique. And now we will discuss about the definite integral. So far we have deal with the things with indefinite integral. Under that part we have just perform the integration using the appropriate techniques. But once you come to the definite integral, uh, actually we are paying our attention for the integral, performing integration within a given interval, within a given value interval we can perform the integration, and this concept is meant to be the definite integral. But when we are using the indefinite integral, we have obtained integral of fx dx as fx plus c, where c is an arbitrary constant. But in the definite integral, we do not need to apply this arbitrary constant. It is because within a given limit, we are performing the integration, and you can see that c is cancelled out once we are applying the concept of the definite integral. If you are performing the definite integral, here you can see that here we need to get the integral of fx with respect to x in the limit of a to b, in the region of starting from a and ending from b. And here we are let these two terms are known as a is the lower limit and b is meant to be the upper limit for this integral. A is the lower limit for the integral, b is the upper limit for the integral. If you get the integral of fx with respect to x for the region a to b, then you can simply take this as, it is quite simple, same as the indefinite integral. Without considering the limit, I will first get the function as fx plus c. It is what we have discussed in the indefinite integral. And even though we come to the definite integral, you can apply each and every concept which we have discussed under indefinite integral in the previous session, as also in the integration by parts technique. We can apply all these concepts in the definite integral, but those concepts has to be now used within the upper and lower limits. Now you can see that after obtaining this function, you can apply the upper limit and lower limit. Therefore, you can use this notation to apply the upper limit and lower limit. If you apply this upper limit and lower limit, first of all, what you have to do is you have to obtain this quantity, and then you have to substitute the upper limit in the in this answer first. First of all, you have to substitute the upper limit in this function or in this answer, then use the negative sign, which means you need to take the difference. Then you have to substitute the lower limit in this function. Therefore, once you substitute the upper limit, then you will get this quantity as capital FB plus C. Since C is a constant, it will not make any change here. The value B will not make any change for C. Only the function value will be changed once we substitute value B in Fx. Then we have to substitute the lower limit here. Then value of x now can be seen, you have to set it as a, since a is the lower limit. Then these two can be connected using minus sign, since we are taking the differences. Then if you go to the theory, first you have to substitute the upper limit, then minus substitute the lower limit in this function. Then you can see that plus c and minus c cancel out. Therefore, in simply you can say now this arbitrary constant c is cancel out. Then the only remaining terms are fb minus fa only. Therefore, if you simply see about what is meant by this equation, this says that we are integrating function fx in the region from a to b, then we will get the answer as the function that we are getting as integration of fx. First of all, you need to apply the upper limit, and then it minus the lower limit value, the function value obtained as substituting the lower limit. And anyhow, this is the basic idea in the indefinite integral, and these are the rules that we will helpful for definite integral. And if you are saying that your function is actually a combination of two functions as f and g, and you are considering the range for definite integral as from a to b, then if it is fx plus or minus gx, you need to integrate this with respect to x in the region of a to b. Here also what you can do is, first of all, you can integrate the functions separately and then perform whether it is addition or subtraction accurate accordingly. And then for these two integrals separately, you have to evaluate the limit for the upper limit as well as for the lower limit of this integral. Therefore, what we can do here is first evaluate the value for fx and substitute the upper limit minus lower limit. Then for gx also we can repeat the same procedure, and thereafter we have to use the addition or subtraction of these two values accordingly as given in the initial function. The second rule stands for if fx is multiplied with a constant called k, then we can take the k out of this integral. It is same as previous in the indefinite integral. For the definite integral also, you can take the constant out of the integral, and thereafter you can perform the integration. In the third part, in the third rule is, it is quite like this. Now think about, you are performing the integration for fx with respect to x in the region from a to b. If you are performing this integration in the region of a to b, and we will let c is a value in between a and b. C is a value in between a and b. Therefore, if you need, sometimes you will this rule will be helpful if you need to define this value for the integral. Then you can say, first of all, you can integrate the function fx in the region of a to c. Therefore, if you integrate the function in the region of a to c, then you can say it is integral of function of fx with respect to x in the region a to c. And then the next region that you need to identify is C to B. The next region is from C to B. Therefore, now you can apply it in here. Therefore, integral of fx with respect to x in the region of C to B. This is how you are using this rule for definite integral. Here, first of all, a to c you have to integrate. Then, starting from c to b, you have to integrate. Therefore, if you see about the ultimate range that they have used is it is from a to b. But here they have considered another stop in the middle of this range. Okay, now we will see some calculations regarding the definite integral. But prior to these calculations, I would like to mention that um, we need to apply the concept that we have used under definite integral prior to apply these limits. Therefore, the, the theories discussed under the indefinite integral will apply first in the function to identify the solution, and for the solution, if it is in the form of a function, then you can substitute the upper and lower limit values. Now we will see how we can perform it. Okay, here we can see there are several examples I have discussed here. The first example is if you ask to get the integral of 6 dx in the region of 1 to 3. First of all, you need to identify the integral of 6 dx without considering about the limit. If you integrate 6 dx, what you can do is you can take the 6 out of the integral since it is a constant, then remaining would be 1 times dx, then this would be 6 times x. This is the function we are obtaining as the integration of 6 dx. Now what you have to do is, now you have to apply the uh, region. Here the region is going from 1 to 3. Lower limit is here, upper limit is 3. Now what you need to do is you need to first substitute the upper limit in the function. Once you substitute 3 in this function, you will get it 6 times 3, then minus, then substitute the lower limit. It is 6 times 1. 6 times 3 minus 6 times 1 gives you 18 minus 6. The calculation should be correct in this form. It is 18, then 6 into 1 is 6, then the final value is given as 2. Final value is given as, okay. Then the next example is the second example. It is you are asked to integrate x squared plus 2x plus 5 with respect to x in the region from 0 to 2. Here also, first of all, you need to evaluate a value for x squared plus 2x plus 5 with respect to x. Then you will get this as x cubed divided by 3. Then 2 times x squared divided by 2, then this plus 5 times x. I have integrate the terms separately, then I can obtain this quantity. Therefore, the prior to substitute the values, it is better to simplify this calculation. Here x squared divided by calculation x squared divided by 3, my plus, here it is x squared, and you will get this as 5 times it. You can say this is the answer which I have obtained, and then you have to substitute the lower limit and the upper limit respectively. First you are substituting the upper limit, then in the place of x, now you have to substitute this value 2, and it is in the first part, then this minus the latter part, you have to obtain it using substituting the lower limit. Therefore, once you substitute the lower limit, then you will get this quantity. Therefore, this quantity will definitely equal to 0 in this example, and the quantity that you are obtaining in this point is obtained as 50 divided by 3. Therefore, this is how we are performing the calculation. The thing that you have to keep in your mind is, first you are using the concepts or the theorems we have discussed in integration first, then you have to obtain a value for this, and then you are applying the upper limit and lower limit respectively and take their differences. And one thing you can see here, now I have omitted this arbitrary constant c. It is because in the concept also you can see that if you apply this plus c here, then it cancel out plus c and minus c in this form. Therefore, we are not going to worry about the arbitrary constant since we are using the definite region for these integrals. The third example, you can see it is in the form of ax plus b to the power n. By applying that concept, now you can obtain the quantity as 2x plus 5 to the power 3 divided by 6. This is what you can obtain using the integration, and then you have to substitute the limits accordingly. Upper limit was 1 and lower limit was minus 1. Therefore, once you substitute the limits accordingly, then you can obtain the answer as 158 divided by 3. In this example, the fourth example, you can say it is actually in the form of f dash x divided by fx dx for the integral. Here you can see function fx is x squared plus 5x minus 7, and 2x plus 5 can be obtained just simply by differentiating function fx with respect to x. Therefore, you can see that or you can just see that this is in the form of integral of f dash x over fx. Therefore, you can get this as logarithmic form. Therefore, the answer would be in logarithmic form for the integration. It would be ln x squared plus 5x minus 7. And now what you have to do is you have to substitute the upper limit and the lower limit respectively. Therefore, once you perform this calculation, then you can say for the upper limit it would be ln 43, and once you substitute the lower limit it would be ln 7. Therefore, here what I have done is use the concept of logarithms. Therefore, if you are having a subtraction of two logarithmic values or just the subtraction of logarithmic function, then you can take it to a one logarithmic function just by taking the division of those two functions. Therefore, that concept is used here. Therefore, we can get the answer as ln 43 divided by 7. In this example, it is in the form of exponential function. First, I have applied the rules associated with integral of exponential, and then upper limit and lower limits was used. Lower limits were used. Then here upper limit was substituted. Here it is the lower limit was substituted. Then the obtained answer is e to the power minus 7 divided by minus 3. Then this minus, once you substitute the lower limit, I have end up with minus e to the power 11 divided by 3. Therefore, the appropriate calculation for these signs and these quantities, then it ends up the calculation as e to the power 11 divided by 3 minus 1 over 3 times e to the power 7. This is what I have obtained. In the last example here, it is asked to evaluate the value for integral of x times e to the power x dx in the region of minus 2 to the 3. First of all, I have to evaluate, I have to obtain the quantity for integral of x times e to the power x dx. Actually, integration by parts techniques was used here to obtain the quantity. You can perform the calculation and you can refer the things that we have discussed in the previous section, and in the beginning of this section we have used the integration by parts technique. Then applying that integration by part technique, you can obtain this answer. Then you have to substitute the upper and lower limit respectively. Therefore, the successful substitution gives you the answer as 2 times e to the power 3 plus 3 over e to the power 2. This is the end of the session, and thank you all for joining with this session.